everybody. We are doing chapter integration, and we have already covered the topic integration of exponential functions and logarithmic functions. Next topic is integration of trigonometric functions. As I have already told when we were doing when we have started this chapter integration, that integration is the reverse process of differentiation. So if you know, and we have talked in detail when we were doing integration of 1 upon x, right? That means if you know the derivative of log x, which is 1 upon x, hence the integration of 1 upon x has to be log x. Similarly, if we know the derivative of some trigonometric function, then if we integrate that function, we should get the original function as the integral. Means to say, if derivative of sin x is cos x, so if you integrate cos x, you should get sin x, and in fact you get integral of cos x as sin x. Similarly, if you differentiate cos x, the derivative will be minus sin x. So if you integrate just sin x without this sign minus, so its integral will be minus sin x. So one thing you need to remember here is that when we differentiate sine function, answer is plus cos x, and when we differentiated cos function, answer was minus sin x. But in integration, since the process is reversed, so negative sign will be applied to integral of sin x, not integral of cos x, right? Means to say, since integral of cos x has to be sin x, since derivative of sin x is cos x, both the signs are positive, right? So integral of cos x has to be sin x, and integral of sin x has to be minus cos x. Now extending this concept to any linear angle, means if sine is given as, if your function sine is given as fx is equal to sine ax plus b, right? So you differentiate this, means you can apply chain rule, means substitute ax plus b as t and then differentiate this with respect to t and obtain hence the value of dx, right? And we have done this in e raised to power ax plus b when we integrated exponential functions, and we have already done this in log function. When any function is of the type 1 upon ax plus b, its integral is ln ax plus b, and that coefficient of x has to be divided. Same thing we will do here, right? So if your fx is cos ax plus b and you are integrating this, that means integral of this will be equal to sine ax plus b, and you divide the coefficient of x, right? Similarly, integral of sine ax plus b is equal to minus of 1 upon a cos ax plus b, right? And we have already, and there is one more function which is sec square x. As we have differentiated tan x, means d by dx of tan x is sec square x, so integral of sec square x has to be tan x. And then you can generalize the angle by using some linear function of the type, not linear function, angle of the type ax plus b, like this. Okay, so here are some formulas that will be used in integration, that, and it says the same thing that I have already spoken of, that d by dx of sine ax plus b has to be a times cos ax plus b. So integral of cos ax plus b has to be 1 upon a sine ax plus b, and of course plus c has to be there, right? So these three basic formulas you need to remember, although again these will be given in MF 19, right? So let us do some examples on this, that we have to integrate the following with respect to x. Let us take first example, which is sin x minus 2 cos x. So if you have to integrate sin x minus 2 cos x, that means I can separate these integral like this, sin x dx, minus integral of 2 cos x dx. Okay, integral of sin x is minus cos x. Please give a special attention to this negative sign. It has to be minus cos x. And similarly, integral of cos x is 2 sin x. Not 2 sin x, 2 is the constant. So integral of just cos x is sin x. And of course, plus c is there. Okay. Similarly, you can find out integral for second part. It is 3 sin x minus 2 cos x. 3 sin x minus 2 cos x plus c. This is minus 5 cos x plus 4 sin x plus c. 4 sec square x. Sec square x means 10x. So it is just 4 10x plus c. Sin 2x plus b will be minus cos 2x plus 1 upon, or you can write this as minus 1 upon 2. Since this 2 is the coefficient of x, plus c. Cos 5x minus pi, you can write this as sine of 5x minus pi, and this is 1 upon 5. You can also reduce this, since you can take minus sign outside. If you can write like this, cos of, taking minus sign as a common factor, you can write this as pi minus 5x. Okay, and pi minus x means pi minus any angle. Cos of pi minus any angle is just minus cos 5x. So first of all, let us convert this into, this is the integral. Either you can convert this final answer by writing this as minus sine 5x upon 5, or you just first convert the given question into a single angle, right, by using the property that cos pi minus theta is minus cos theta, or you can apply the same property after integrating this. Okay, so if you are applying this property beforehand, means before integrating, so this is cos minus theta is cos theta, and cos pi minus x or cos pi minus 5x is minus of cos 5x. Now you can integrate this, and this will be minus sine 5x upon 5. This is your final answer, right? You can reduce this after integrating, means sine 5x minus pi can be written as, taking minus sign outside, this will be sine pi minus 5x, right? Because sine minus theta is minus sine theta. That's why minus sign can be taken outside. And now sine pi minus 5x is just sine 5x, because sine pi minus theta is sine theta. So this is minus sine 5x upon 5. Same answer you are getting. Okay. Sixth part is 6 sec square 2x. Directly writing this as 6 over 2 10 square 2x. 10 2x, sorry. 10 2x. 3 sec square 3x is 3 by 2, sorry, 3 by 3 means 1. 10 3x minus sine 2x is minus of minus means plus cos 2x over 2. Okay, sine ax plus b, here b is 0 and value of a is 2. So sine 2x is minus of cos 2x over 2, and that minus and minus will become plus. So plus cos 2x over 2. Right. Similarly, ninth part you can write this as 4 10x minus cos integral is plus sine, so minus of sine 2x over 2 plus c. Right. Next, find the exact value of sine 2x minus cos 4x, its integral from 0 to pi by 3. Okay, let us do this. Sine 2x minus cos 4x means you can separate this integral, sine 2x dx minus integral of cos 4x dx. Sine 2x integral is minus cos 2x over 2, and this is minus of sine 4x over 4. And remember, this upon 2 is whole upon 2, not in the angle. Otherwise, this will become just x. Okay, means first find out the value of cos 2x and then divide it over by 2. Divided by 2. Now put the limits. Your lower limit is 0, upper limit is pi by 3, means 60 degrees, 0, pi by 3. So minus cos 2x is minus cos 2 pi by 3. Okay, this is upper limit, minus of lower limit. So minus and minus, this will become plus cos 0 upon 2. Right, this is the value of upper limit minus lower limit for this function, and minus sine. Upper limit is sine 4 pi by 3 over 4, minus lower limit is 0, so sine 0 over 4. Okay, I'm writing moving anti-clockwise. Cos 2 pi by 3 can be written as cos pi minus pi by 3, which is minus cos pi by 3. Right, cos pi minus pi by 3 is minus cos pi by 3. Or you can just use your calculator, and I don't know whether the calculator will give you the exact value. My point is that if the question is asking about the exact value, that means you have to show some algebra. Means you need to remember the values of, you need to write the answer in surds form, right? So cos pi minus pi by 3 can be written as minus cos pi by 3. That means this cos this can be written as plus cos pi by 3. Cos 2 pi by 3 is cos pi minus pi by 3, means again minus cos theta, so minus minus will become plus, so plus cos 2 pi by 3. Cos 0 is 1, so this is 1 over 2, minus sine 4 pi by 3. Now 4 pi by 3 means the angle is now in third quadrant, so this 4 pi by 3 can be written as sine pi plus pi by 3, so minus sine pi plus pi by 3. Now since sine pi plus theta is minus sine theta, right, so this is minus sine pi by 3 over 4, and sine 0 is 0. Okay, so cos pi by 3 is cos 60 degrees, which is 1 by 2, plus half, minus minus is plus 1 by 4, sine pi by 3 means sine 60, which is root 3 over 2. 1 by 2 is, I think, 1, right? This is 8, so 8 plus root 3 over 8. Okay, I think this has to be the answer. I hope I have done the calculation right. And if the calculations are wrong, no matter, just understand the concept that you have to apply the limits very carefully, means to say. Okay, let us do the next one. Using trigonometrical identities in integration. Now we know that in trigonometric chapter we have learned some basic identities. One identity in the A level, we are using the properties or identities that we have learned in AS level, means sin square theta plus cos square theta is equal to 1. That is a basic identity. Also, we have learned some identities which involves sec square, tan square, and cot square and cosec square, means the identities which involves reciprocal trigonometric functions. Then we learn about some compound angle formulas, that sine 2 theta is 2 sine theta cos theta, and there were 3 formulas for cos 2 theta, which is cos square theta minus sine square theta, 1 minus 2 sine square theta, and 2 cos square theta minus 1. Right? Similarly, there are compound angle formulas for tan to theta. Why I am saying this? Because if you are doing this integration of sine square x by using the formula that this has to be sine cube x over 3, means writing this integral as sine x whole square dx, and using the formula for x raised to power n integral is x raised to power n plus 1 upon n plus 1, this will be wrong. Why this is wrong? We will use the differential method, means if we are able to get the original function by differentiating your answer, then your integral is correct. So if let us differentiate this sine cube x by 3, means considering your answer as correct. So by differentiating this sine cube x upon 3, I should get sine square x, right? So differentiating this with respect to, first let us say taking 1 upon 3 as a constant, differentiating sine cube x with respect to sine x, which is 3 sine square x. So far so good, you are able to get sine square x, but again here you have differentiated this with respect to just sine x, right? But integral is with respect to x. That means its dy dx is not yet completed. You have to differentiate this sine x now with respect to x, which is cos x, right? So your derivative function is sine square x into cos x, right? That means if your function is this, then you can say that integral of sine square x is sine square x cos x. Alright, but this is not the case. Your original function is just sine square x, not sine square x cos x. Right? That means this method, that since there is a power, you can increase the power by 1 and then divide by n plus 1. This is wrong. Okay, this is wrong approach. So what is the correct approach? Correct approach is that if there are sine square x and any function of the type sine square x or cos square x or sine cube x or cos cube x or cos raised to power 4x, means if trigonometric function is raised to some power, then these has to be reduced to double angle formulas. Converting these exponent trigonometric functions into some double angle terms, means converting into either sine 2x or cos 2x. Sine square x doesn't come under sine 2x, nor it comes under tan 2x, but there is one formula which involves sine square x and double angle, which is cos 2x, okay, that we have learned in the chapter trigonometry. So my point is, we have to convert these into double angle formulas by using this formula, that cos 2x has three formulas, which is cos square x minus sine square x. As far as integration is concerned, we won't use this formula as much as we will use the following two formulas, which is 1 minus 2 sine square x, and third formula was 2 cos square x minus 1. Because either the integral will involve sine square x, that means we have to use this formula, or if the integral is just integral of cos square x, then we will use this formula. Again, I am repeating why we are using these formulas, because these cannot be integrated, or this cannot be integrated directly, right? All these has to be converted to double angle formulas. If there is cos square x, we will use the formula for cos 2x, which involves just cos square x. If it is sine square x, we will use the formula which involves cos 2x and just sine square x. Okay, so for this particular question, we will use this formula. Okay, 1 minus 2 sine square x. Now from here, let me clean this up. Once I know that I have to use this formula, cos 2x is 1 minus 2 sine square x, that means I can write sine square x as 1 minus cos 2x over 2. Okay, so writing this as integral of 1 minus cos 2x over 2 dx. Now this can be separated, half dx minus cos 2x, again half here dx. Okay, 1 upon 2 dx minus integral of cos 2x upon 2 dx. Integral of half is just x, so x over 2 minus half as it is. Cos 2x integral will be sin 2x upon 2, and that upon 2 and this 2 will be 4. So I am writing this directly, that this is minus 1 upon 4 sin 2x plus c. Okay, this is your integrand or the final answer. Okay.